Okay. Part of your exams are on Friday. You have your literature and your science on Friday, except Monica because she did hers last week with chemistry. But anyway, you have your biology and your literature, the rest of you. On Tuesday, I think is when you all will have your grammar. And then on Wednesday, you'll just have review sessions with a review session with me and making up any stuff you still owe me. And then on Thursday of next week is when you'll have your geometry exam. But like I said, I'll send out the schedule because like we tried to alternate it where like, you know, you have the science one's big, your literature exams are little, so that's why they're doing them on the same day. And then we tried to make sure like your grammar one and your math one were different days, so you don't have two big exams on a day. So I will get that schedule sent out to you all, so you have it this afternoon. So it'll be as an attachment, and I'm sending it to you all and your parents, but it has the schedule for Friday because we're getting exams Friday. Friday won't be a normal class day. You'll still have classes, but they may be at different times because of when you're doing your science exam. So you have to pay attention to the schedule and the times, but you'll have Friday on there and then Tuesday, Wednesday, and Thursday of next week. You don't have anything next Monday because that's Memorial Day. So you can think of that as your rest makeup day because some of you still have a lot of stuff you gotta get made up. Okay, so let's get started on our similar figures. We'll get started on our similar figures. We're gonna be talking in section 11.1. Now we know, everybody knows what congruent means, right? Everybody knows what congruent means?
Yes.
Same size, same exact shape, everything's the same, okay? Similar figures are different. Similar figures are the same shape, but they're not the same size, okay? Now the angles, the corresponding angles in the same spot, just like we had corresponding parts when we did congruent triangles. You remember that little thing CPCTC that y'all kept trying to remember what it stood for when we were doing proofs? Okay, corresponding parts of congruent triangles are congruent. Corresponding parts of similar figures are two different things. Angles are still congruent. The sides are proportional, which means they have the same ratio. Now remember, when they talk about a ratio in math, it's usually written as a fraction. So we'll be doing a lot with proportions the next couple of days. Okay, and this is stuff that was on those chapter 11 notes if you did work on those any yesterday. With the proportions say two ratios or two fractions are equal to each other. So we're going to be working with that a lot as well. Now when we're starting on these, we're going to start by just talking about our ratio or scale factor type thing, getting those written, and then we'll talk about some where we're actually solving proportions and then applying it to our similar figures. Okay, so we're going to try to go through these fairly quickly today, and then that way at the end, if anybody hadn't done the quiz yet that I sent yesterday, which was really easy by the way, because it was basically just filling in the blank with the definitions. So if you have your book or your notes, they were all pretty much right there, okay? So if you have any questions on that, that way you can ask me at the end. So looking at this, we're going to be working on page 521 first. So everybody make sure you got your book and it's open to 521. And we're going to read through these and do whatever it asks us to. Okay. So on our first one here, for number 1, it says find the scale factor. Scale factor is written as a ratio, so that means we're going to be writing a fraction. For a 36-inch tall scale model of the 288-foot tall United States Capitol building. Okay, now first of all, one of our units is in inches and the other unit is in feet. So I need to get it where they are in the same units, okay? So how many inches is a foot?
12.
12. So if I have 36 inches, that's going to equal how many feet?
3.
3. Okay, that's 3 feet. It's a yard. But anyway, that's not point. Okay, so I've got 3 feet. So what I'm going to do is now I'm going to take my scale model. Your model or your drawing goes on top. The real life thing goes on the bottom. So I have my ratio will be 3 feet over the 288 feet. Okay, 3 feet over 288 feet. Now, you always, always, always have to see if you can reduce your fraction. Now, if you're not good with that, you can always type it in on the calculator and it will reduce it for you. Okay, or you can divide it and it'll reduce it. However you want to type it in. But 3 goes into both of those. Okay, 3 goes into both of those. By the numerator and the denominator by 3. So I get 1 over 96 is my scale factor. Okay, that's my ratio of the model to the real life Capitol building. Okay, now on number 2, we're going to be writing ratios as simplified fractions. So again, anytime you're working with these, you've got to make sure it's reduced to lowest terms. It says in a class of 30 students, 18 students are in the school's band. Write each ratio as a simplified fraction. So band members to students, there are 18 band members out of 30 students. So I have 18 over 30. What goes into both of those?
4.
No, bigger.
6.
6. Okay. So then you just divide them both by 6. And I get 3/5. So the ratio of students in band to the total students in the class is 3 to 5. Okay, that's all you do. Now, part B says non-band members to students. So if 18 are in band, I'll take 30 minus 18 to see how many are not in band. So what's 30 minus 18?
12.
So 12 students out of the 30 are not in band. And again, I have to reduce it to lowest terms. Again, 6 goes into both of them. So I have 2/5. Okay. Brian, take that to Dad and see if he uses that. Sign me up or something, I don't know. He sends stuff to my phone. All right. So everybody got that? Yeah, pretty easy? Okay, what's our last one? Part C says band members to non-band members. So how many band members were there?
There was 18
were band members. 12 were not band members. So it's 18 over 12. What goes into both of them?
6.
6. 18 divided by 6 is 3. 12 divided by 6 is 2. Okay. If you had noticed with what they reduced to, 3/5 and 2/5 had to add together. The students that were in band and the students who were not in band had to add to equal the whole class, which would have been 5/5 or 1. So it makes sense. Okay, that's the way you can check yourself. Make sure it adds to 1. Now, that's just writing the ratios. Okay. Now, after we have ratios written, a lot of times they will have them set equal to each other in a proportion. So we have to solve a proportion. Does anybody remember how to solve a proportion?
No,
This is something you should have done since like elementary school,
I forgot.
or at least middle school.
it's out of my brain cells, so I don't know.
We cross multiply. We cross multiply. You multiply what they call the means, the middle numbers. So 3 times y is 3y. And then that's equal to the product of the extremes, the first and last numbers. 18 times 2 is 36. And then you just have a regular equation that you can solve to get the y by itself. You have multiplication here, the opposite of multiplication.
Division.
Divide by 3, so I get y is 12, and that's it. Okay, you multiply the means by the extremes. Okay, the middle numbers by the first and last number, the outside numbers. Okay, now we're going to do the same thing on number 8. Okay, remember if you pay attention up here, I said we're doing 1 through 3, then we're skipping. We're doing 8 through 11, and then 14 to 16. Okay, we're just trying to make sure that you kind of got the basics out of this. Okay, now on here, we do the cross multiplication again. You just got to be a little bit more careful on this one. Okay, because you have this number, that you've got the expression up here. So I will have 15 times z minus 2 is equal to 10 times z plus 7. When you are multiplying like that, you have to multiply the 15 times the entire numerator on the top and the 10 times the entire numerator on the top on the other side. So we end up having to use our friend that never goes away, the what property? Distributive property. Yeah, take what's outside, multiply it by both things inside. So I just take the 15 times the z and the 15 times the minus 2. So 15 times z is 15z. 15 times the 2 is 30 equals. Now I'm going to do the same here. 10 times z is 10z. 10 times 7 is 70. Now, when we get to this point, we're always trying to get the variable by itself. So to be able to get z by itself, I have to get where there's only one z. Right now, I have 2 z's. I have z's on both sides. So I have to move the 1 over. Excuse me. So since I have a positive 10z, and I gotta move it over, I'm going to subtract it. So I subtract 10z here. Whatever I do on one side of my equation, I do to the other. 15 minus 10 is 5. And then on the other side, I still have the 70 left. Now, we have solved equations like this throughout the entire year. We've had different problems where they'll throw stuff like this in there to make sure you remember stuff from algebra. That's why you took it after you've had algebra, because you have to use algebra to solve some of these problems. When we're solving equations, you get where there's only one variable term first. Now I have to get the variable term by itself. So I have 5z minus 30 equals 70. So I got to get rid of the minus part now. How do I get rid of a minus?
You add it.
Add. So I add 30, whatever I do on one side of an equation, you always do to the other. So I have 5z equals 100. I have multiplication now to get my variable completely by itself. I divide by 5. So I get z is 20. So you have to work your way all the way through to get the variable by itself. Now, a lot of times the proportions that they give you that you're going to have to solve are more like this first one. But I want to make sure that you still remembered about these, because we have had other problems throughout the year that had that on there. So if you get one on the exam next week where you have to use distributive property, or you have to get variables on one side, just to kind of refresh your memory of how to do that. Okay. Now, start with number 10 and number 11 is getting into where it's actually talking about our similar figures. Remember, similar figures are the same shape, they're just different sizes. One's going to be larger than the other. Okay. Now, when you were talking about the similar figures, the corresponding angles, the angles that are in the same position, how they relation to the figure, are congruent, and the sides have the same ratio, the corresponding sides. So what we're going to do on 9 and 10, it says write a similarity statement for each pair of similar figures, then write an extended proportion relating the lengths of their sides. So when you're talking about a similarity statement, it's like a congruent statement. We wrote those all the time when we were doing our congruent triangles. You would say triangle ABC congruent to triangle DEF. And then you knew that meant angle A matched the angle D, etc. You could match up the corresponding parts. Same concept. So if you look for number 9, you have to look at the ones that are marked the same. Now, usually we try to put our letters in alphabetical order for like the first one at least. So I'm going to call it triangle ABC. And I'm going to say it's similar to, and then I got to make sure I match them up. So remember, those little arcs on an angle show you what's congruent. So what angle is the same size as angle A? Look at the other picture. What's marked the same? Angle
D.
D. Okay, A has one single mark, D has one single mark. Okay. What matches up with B?
F.
F. And then E matches up with C. Okay, so you have to make sure that you get them in the right order when you're writing your similarity statement. Trying to get it where it's up closer without the glare across the problem. I think it's the same as everything. I'll just say it. All right, so number 9. We did that. Now we're writing the sides that go together. So when you're writing the sides, you're writing ratios. AB, that's the first 2 letters of this one, go with what in the other one? What do you have tomorrow?
DF.
Okay. AB goes with DF, so you put AB over DF. You're just writing the ratios of the sides that go together. BC.
What F? E.
All right, BC goes with what?
FE.
BC, second, third letter goes with FE, second and third letter. And then for the last one, you do first and last. So I have C and then go back to the beginning. C goes back to A, so E goes back to
D.
D. You're just writing the ratios of those sides, okay? You're just writing the ratios of those sides. Pretty easy? Okay, you're just looking to see what matches up. Now, on number 10, what shape are those in number 10?
What was it again?
On number 10, what shape are that? And you all, there is more than one person in this class. And if some of you all don't start answering other than Javier, then y'all are just going to be on your own for this last week.
Trapezoid.
Thank you. There's no reason to just have one person answer. Y'all know better. All right. So they're trapezoids. So when you're naming the trapezoids, I'm going to do the first trapezoid on the left in alphabetical order. So I have JKLM. And that's similar to, and then I have to match up what is in the same position as J in the second trapezoid. So you look, it's just turned sideways, right? So J matches up with Q, R matches up with the K, and you follow it around, S and P. I don't know why I stuck a comma there, but okay. Q, R, S, P. You just follow it around, what matches up. Now we do our sides like we did up here. So JK, first and second side. First, second go with QR. KL goes with RS. LM, I just keep using the next two letters. LM goes with SP. And then I'm at the end, so MJ goes with PQ. You work your way around writing your ratios, okay, for the similar figures. Now, the reason they had you practice writing these ratios of what went together is because on 11, 14, and 16, you're actually going to be looking and figuring out the scale factor, like matching up sides that go together to find the scale factor, kind of like what we did up on number 1. And using that scale factor to write a proportion, like we solved up here in number 3, to get the missing side. Okay, so we're looking at number 11 next. Okay, we're looking at number 11 next. On number 11, it says, find the similarity ratio of the red polygon to the similar black polygon. So we're starting with the red polygon as our first one. So we're starting with the little one. So you look at it and you find a side that matches up. So I always usually pick, like, if you look, are they turned the same way? They're turned the same way, right? So I usually just use like the bottoms because it's straight across. It's a little bit easier. So I have 14 over 21. Now what goes into both 14 and 21?
7.
7.
So my ratio is 2/3. Now, if you put your other pairs of sides together, if I do the left-hand sides, I have 10 over 15. That reduces to 2/3. If I do the diagonal sides, I have 20 over 30. That reduces to 2/3. Your corresponding sides all have that same ratio if they're similar figures. Now, using that fact on 14 and 16, we're going to find missing side measurements. So looking at number 14, it says find the value of each variable in each pair of similar polygons. So on number 14, you look at it. Which pair of sides do you know is the same in both? The bottom, right? The bottom side is actually labeled with a number on both triangles. So that's my main ratio that I'm going to use, okay? That's my main ratio because I already have that there. So I know 24 goes with, what is that, 18? Right? 24 goes with 18. Everybody get that? You see what I'm talking about? That's my main ratio, the bottom of the left triangle and the bottom of the right triangle. Yes? Okay, I'm going to reduce that to lowest terms. What can go into both of those?
6.
8.
6 can go into both of them. 24 divided by 6 is 4. 18 divided by 6 is 3. So this is my scale factor. Like on number 11, we found it was 2/3. On this one, it's 4/3. So I'm going to use that scale factor to find my missing sides. So I have 4/3 is equal to, and then the first one we have M and we have N. So M is right here on the top. It's in the big triangle. So if I had big triangle on the top here, I have big triangle on the top on the other side. M matches up with what side in the little triangle? It's in the same position as
12.
12. M is in the same position as the 12 up here, right? Y'all see what I'm talking about? It's on the top right, goes with the top right. So we cross multiply like we did on number 3. So 3 times M is 3M. 12 times 4 is 48. Is M by itself yet? No. Divide both sides by 3. I get M is 16. Now I am not done because it also wanted N. So I have 4/3 is equal to what matches up with N? All right.
9.
So I have N over 9, right? Top left to top left. Cross multiply. 3 times N is 3N. 9 times 4 is 36. Divide both sides by 3. N is 12. So I got my missing sides there, okay? We're using our proportions to find our missing side. Okay, now looking at number 16. On number 16, what we are trying to do is the same thing. You've got your similar triangles. You pick your pair of sides that are marked in the same position and find your scale factor. So if I'm looking, trying to find my scale factor, I have the 2 sides going straight up and down. So my scale factor is going to use what 2 numbers? 30 and what?
20.
30 goes with, you're picking from the first triangle and what it matches up with in the second.
Oh, R.
You say
Oh, no, it doesn't.
18.
18.
18.
Good. So the 30 goes with the 18, okay? You're looking for what's in the same position. Those are your corresponding sides. So now we're going to reduce this to lowest terms, okay? Biggest thing that goes into both of those is 6. 30 divided by 6 is 5. 18 divided by 6 is 3. So my scale factor is 5/3. So that's what I'm going to use to do my proportion. Okay? So I have 5/3 is equal to, and then I've got to set my proportions. So on here, we are looking for R and we're looking for S. So you find where R is in your triangles. R is the top right-hand side. Everybody see that? Everybody see R is on the top right-hand side of my little triangle? So what goes on the top right-hand side of my big triangle? That 25. So I have 25 over R. So sometimes your R can be in the bottom, sometimes it can be in top, doesn't matter. Cross multiply. 3 times 25 is 75. R times 5 is 5R. Finish solving by getting R by itself by division. So R is equal to 5 goes into 75 15 times. Now we have to find the other one. Still use my same scale factor. 5/3 equals, and then what's going to be my ratio on the other side to find the S? Which one's going to go on top? The S or the 12?
The 12.
Nope.
S.
The S goes on top because Did one of those work? Okay. The big triangle was on top here, so the big triangle has to be on top on this side. That's the main thing you need to remember. You've got to match them up. So now I cross multiply. 3 times s is 3s. 12 times 5 is 60. Divide both sides by 3 to get s by itself. So I get s is 20. So you had r is 15 and s is 20. Okay? So that's your basic similar figures. Okay? Uses corresponding parts are in the same position and uses proportions and scale factors. Now, section 11.2. On section 11.2, it works with proving similar triangles. Now, if you remember, did we have different ways we could prove triangles congruent? Tell me if any of this sounds familiar. Side, side, side. Side, angle, side.
Yeah.
Angle, angle, side. Does that sound familiar? Those were ways we could prove triangles congruent if the corresponding parts were in the same spot, they were congruent. Okay? We do the same with similar triangles. There's some of those rules. One of them is there on page 525. It says if 2 angles of one triangle are congruent to 2 angles of another, then the 2 triangles are going to be similar by angle, angle, similarity postulate. Okay, so AA. Okay, because if 2 angles are congruent, the third angle is also going to have to be congruent because all 3 angles always add to equal what in a triangle?
180.
180. I'm trying to review with you a little bit here as we go along too. Okay, 180. So if I know 2 angles are the same, then the third one's going to be the same because they still have to add to equal 180. Okay, so that's one way that we can prove triangles similar. Another way is on page 526, and that's side, side, side. If all 3 pairs of corresponding sides have the same ratio, then the triangles are similar. So that's kind of similar to what I talked about up here to number 11. When we matched up whichever pair of sides we used, we still would get 2/3. You had 20 over 30, which was 2/3. We had 14 over 21, which was 2/3. You had 10 over 15, which is 2/3. They all had that same ratio. Then they're going to be similar by side, side, side. And then the last one's at the bottom of page 526. It says if 2 sides of one triangle are proportional to the corresponding sides in another, and the included angles are congruent. Now remember, we talked about this a lot when we did our triangles. For congruent, included means inside. So it means I'd have this side matches up with this side. This side matches up with this side, and the angles that are included where those 2 sides meet are the ones that would be congruent. And remember, for congruent, they match them up with that little arc. They usually have that arc drawn on there. Okay, so that's what we're working with in 11.2. Is the different ways we can prove triangles similar. Okay. So we have angle, angle, we have side, 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 and we have side, angle, side. Okay, so look on page 528. Look at page 528. Okay, on page 528, it says if the triangles can be proved similar, write a similarity statement. So that's like triangle ABC similar to triangle DEF. And name the postulate or theorem that justifies it. So that means the angle, angle, the side, 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 or the side, angle, side. Okay, those are our 3 choices. So looking at number 1, you look at the markings that it gives you on the triangles, okay? You have angle B is marked that it's congruent to angle F. You have angle C is marked that it's congruent to angle D. So if I have 2 angles of one triangle are congruent to 2 of the other, then can they be similar? We talked about that. That's the first one I read. Yes. So triangle ABC, I always usually try to put the first one in alphabetical order, is similar. Now you'll notice our symbol for similar is just the squiggly. Remember, for congruent, it was the equal sign with the squiggly over it. This doesn't have the equal sign, it just has the squiggle part, okay? So ABC, so A matches up with the angle that wasn't marked, which was E. B had 1 arc, so it matched up with F that had 1 mark. And then C had 2 arcs that matched up with D. So those 2 triangles are similar by angle, because the 2 angles of one were congruent to 2 angles of the other. Okay? So that's all we do on here. Let's look at number 2. Page 528, number 2. You've got 2 triangles again. If you look, you have an angle marked that's congruent. Okay, I can't read those letters, but you can see them. Okay. Angle G is congruent to angle L. They're both marked the same. Now I need to check the ratios for the sides. Okay, because I don't have any other angles marked, so I can't just assume I'm by AA. So 10 goes with what side in the other triangle?
5.
10 matches up with the 5. They're in the same position, which reduces to 2. And then the 8 matches up with what?
4.
4, which also reduces to 2. So they have the same ratio, right? So I have the 2 pairs of sides that have the same ratio, and the included angle, the angle connecting those 2 things together. So I can say they're similar by side angle side. So I'm going to say triangle GHI is similar to triangle, and then G matched up with L, H matches up with J, and the I matches up with K. So GHI is similar to LJK. See how this works? Yes, no, maybe? Okay, let's do another one. Let's say it's number 3. You got 2 triangles. Now these are turned different directions, so you got to be a little bit careful because they don't look like they're turned the same way on this one. So what you do is, you know, the largest side of the first one has to go with the largest side of the second one. The smallest side has to go with the smallest side, and then the in-between side goes with the in-between side. So what is my biggest side in the first triangle on number 3?
16.
So 16 goes with the biggest side of the other triangle, 8. And then I reduce that to lowest terms. Why am I dividing by 4? Because 8 goes into both of them. So I get 2 again, right? Okay. Now my next largest side was 12. What's my next largest side in the other triangle? 6. It also reduces to 2. What's my smallest side in the big triangle?
8.
And the smallest side in the little one? 4. So it still reduces to
2.
Huh? Yeah. Okay. So we have this here. Okay. So they're all the same. So then I can say the triangles are similar by side, 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 because all three pairs of sides have the same ratio. So I'm going to say triangle MNO is similar to triangle. So I got to be careful here. M is down at the bottom of the big side, and it goes up the shortest side to the N. So starting over here, I'm starting at the bottom of the biggest side, but I got to go up the shortest side, so that's the R. And then it goes up to Q and P. You've got to be careful and make sure you get them in the right order. Okay? So we're just proving them similar. Right in the ratios. Okay? So, what I want you to try to do is look at number 4, 5, and 6 and figure out whether or not you think they're going to be similar. Okay? Yes. And then same thing on number 12, 14, and 16. Look at what they have on there. See if there's anything that you see that's marked that you think you can say they're similar to each other. We have how many ways that are similar? These are your 3 ways. Angle, angle, side, angle, side, 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 side. On number 12, 14, and 16, one of them is going to be by angle, angle. One of them is going to be by side, angle, side. And one of them is going to be by side, side, side. So I want you to just figure out which one's which. Okay? And then we'll finish up with that tomorrow. Everybody understand what I'm talking about? Yes? No? You got to ask. Speak up.
Yes, ma'am.
Okay. So on 12, 14, and 16, you look at those pictures based on what's marked. Remember what those little red arrows mean. Remember about vertical angles are always congruent, all those kind of things. Figure out whether they're going to be similar about angle, angle, side, angle, side, 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 side. And then also look at 4, 5, and 6 and see if you can figure out if they're similar or not. And then we'll pick up with that there tomorrow and then talk about similarity in special and just in right triangles and go from there. And like I said, I'm trying to kind of go through. Did anybody have a question on the quiz I emailed yesterday before you log off? If you don't, you're good. You know what you got to do, and I'll see you tomorrow. If you do have a question on the quiz, stay on and ask me.
I'm going to do it today, miss. The quiz.
Good. That'd be good. I'd like that. Do it today. Send it to me when you do it. Okay?
Got you, miss.
All right. Bye.
Bye, Miss Pam.